So now that we have the concept of running things in the background, right? Now we can run computations in the background. That then raises the question of how do we wait for stuff that's running in the background to finish so we can get the results? Sometimes you just want things to run in the background. They do whatever they do. They print the results through some side effect, all is well. Other times, however, you want to wait for the call to finish and then get its result back in the main thread for whatever reason. So to do this, we're going to talk about blocking operators. And these operators block, that's why they're blocking operators, awaiting a mono to emit its value, its one and only value. And we're going to talk about two of these methods, block and block optional. And the thing to remember here is the mono that is emitting the value that we care about is typically running asynchronously in a background thread, a different thread of control than the thread that's calling block. So that's important. We're waiting for something else to finish. So let's talk about the block operator first. What this does is it subscribes to the mono it's called on, usually in a fluent chain, and it will block until a next signal is received. And it returns the value that's received if we got a value, or it return null if the mono happens to complete empty because there was some kind of error. If the mono errors, the original exception is thrown. So if the thing up the chain threw an arithmetic exception, then that will be what's thrown from block. And any checked exceptions are wrapped in runtime exceptions, just to make things cleaner. You don't have to use all the crazy try-catch block nonsense that comes by using checked exceptions in Java. There's also a timed version of block that blocks until a next signal is received or until a timeout expires. So you can see here we have duration, which is the timeout, and that'll block up to that duration. If the provided timeout expires, a runtime exception is thrown. And as Yoda puts it so well, there is no try, only success or runtime exception. Actually, I have no earthly idea why someone took the time to make that meme, but it's completely 100% relevant for this particular use case. People clearly have too much time on their hands. So block internally, block calls the subscribe method. Now, we really haven't talked much about subscribe, but subscribe is the thing that sets all the wheels in motion, as we show here. And that is what initiates all the processes. Remember how we've talked about things like streams and parallel streams where you have terminal operations and nothing happens until the terminal operation is hit? Well, the same thing holds true for Project Reactor with subscribe. Until subscribe is called, nothing starts to run. And if you take a look at the implementation of block, this is actually a snippet of the implementation of block from the source code, which you can get here. What that does is, as you can see, it creates a new blocking mono subscriber. This is the implementation. And then it goes ahead and it subscribes, and then it returns subscriber.blockingGet, which will wait up to a certain amount of time. So that this is lower level calls, but basically what this is doing is it's saying block will subscribe. We typically use block if we need to get the value from an asynchronous computation, and we absolutely have to have it before we do the next thing. So in some sense, it's a bit like join or get in the context of completable futures or futures, where you finally reach a point where you're like, I've done enough asynchrony, I've got to wait for the results. So here's a very simple example that illustrates what we do here. We will use mono from callable to multiply two big fractions together. The big fractions, of course, are defined up here with some values. We then use subscribe on to run the multiplication in a background thread, and then we block, waiting for that background thread to finish. We get the result, we print the result. Notice how absurdly concise this code is. It's so freaking cool. What we're saying here is, do the multiplication computation in a background thread, and then block the calling thread, waiting for the result. And I'll show you an example to demonstrate how that works when we get to the case study here in a minute. RxJava has a similar operator called blockingGet, which, as you can see here, works like this. Same basic idea. In fact, it's very, very, very similar. Just it's called blockingGet, not block. As I mentioned before, block or time block or whatever, actually not time block, the block, the non-time block, is very similar to completable future join. So here's a similar example where we've got something running asynchronously in the background as a result of calling supply async, and then we say print the results, f.join, that'll block until that computation is finished. The next operator I want to talk about here is called the blockOptional operator. And this is very similar to block. The difference is it subscribes to the mono and blocks until the next signal is received or until the mono completes empty. So what it does is it returns an optional. Now, we've talked about optional before in other contexts. We talked about that in the context, for example, of completable futures. And basically, an optional is just something that either has a value or is empty. So you can either be empty or you can have an actual value. And you can also replace the empty case with an exception using something called optional.orElseThrow. That's a little bit of a discursion, a little bit of a digression, but it's just there if you need it. You can also get a return value by using orElse or orElseGet. And you guys have got some experience using orElse in some of the programming assignments for optionals. The whole purpose for using optional is to eliminate the dreaded Java null pointer exception, which will otherwise occur if you get back an object that doesn't have a value. Instead, it's a null pointer, and you try to make a method call through a null pointer, and then you get the null pointer exception, and the world ceases to exist as far as your program is concerned, usually. So optionals avoid getting null pointer exceptions. There's also a timed block optional that will block until you get the signal or until a timeout expires. And once again, if the timeout expires, a runtime exception is thrown. So here's an example of using block optional. This is kind of fun. It's very similar to what we saw before. As you can see, we use mono from callable to multiply two big fractions together. We arrange to run those things in a background thread. And then we call block optional, which blocks the calling thread until the background operation is done. But if it turns out that there's no result that comes back, in this case there will be, but if there were no result that came back, then we would get back an optional that was empty. Whoops. And if you said result.map, then this code would not be run if we got back an empty optional. If you get back a non-empty optional, then we'll convert it to a mixed string. If we get back an empty optional, we'll just return the string error using orElse. And we'll look at that example more in a second. Oddly enough, there is no direct RxJava equivalent for this. Go figure. You can use blocking get to wait for a result, but you don't get optional behavior there. And once again, this is also very similar to completable future join, except it doesn't return an optional. So that's the end of our discussion of blocking operators in the mono class.